You know, when we look up at the night sky, it's so easy to picture space as this silent, peaceful, perfectly ordered clockwork machine. But today, we're going to completely shatter that illusion. We're diving right into how the universe actually works. And spoiler alert, our perfectly habitable Earth, and really the fundamental rules of the cosmos, are the result of a chaotic, violently unpredictable sequence of cosmic accidents.
So, how did we get here? Well, we have to totally throw out the idea of a gentle, peaceful solar system. Instead, we need to look at a universe driven by high-speed collisions, gravitational bullying, and just absolute chaos. To understand how we ended up existing at all, we have to trace a literal cosmic butterfly effect, where these ancient catastrophes actually paved the way for life. Act 1. The Hasty Giant. We're starting our journey out at Jupiter, a massive gas giant whose incredibly frantic formation dictated the fate of basically everything else around it. See, when the Juno space probe finally arrived at Jupiter to peer deep into its dark heart, scientists totally expected to find a solid, dense, rocky core, kind of like the pit of an avocado. But Juno's gravity measurements revealed something entirely different. Jupiter's core isn't solid rock at all. It's this weird, fuzzy, dissolved mixture of hydrogen and rocky material all blended together. As one astronomer brilliantly put it, it's like a hydrogen fluid chili con carne. This discovery completely rewrote the book on how giant planets actually form. Now, to get its core that wonderfully weird, Jupiter had to grow incredibly fast. It did this through a process called pebble accretion. Instead of waiting around for hundreds of millions of years for giant rocks to slowly crash into each other, infant Jupiter acted like a giant cosmic vacuum cleaner, gobbling up tiny, centimeter-wide drifting pebbles. This feeding frenzy accelerated its growth 1,000 times faster than normal, letting it build a massive core incredibly quickly. But why the rush? Well, Jupiter was up against a really strict time limit. Young stars give off these violent bursts of radiation, meaning our infant sun was acting as a ticking clock. After just about 5 million years, the sun blew the surrounding disk of gas completely away. If Jupiter hadn't used pebble accretion to reach a critical mass of 20 Earths within that tiny 5 million year window, it literally never would have had the gravity to capture the gas that makes it the giant we know today.
Act 2. The Tale of Two Planets.
Let's zoom into our inner solar system and look at a stark contrast of survival between two neighboring rocky worlds. They started with very similar potential, right? But today, Mars is famously a spacecraft graveyard, a barren, freezing desert. And the reason why comes down to size. When Mars formed 4.5 billion years ago, building materials were scarce and its growth was stunted. Earth, on the other hand, is a factor of 10 larger. That extra mass, it is absolutely everything. It allowed Earth's internal core to stay hot, churning, and liquid, which generates a massive magnetic shield. Because Mars was just too small, its core cooled off, its magnetic field died, and the solar wind literally peeled its atmosphere away into deep space. Now, you might look at our large, protected Earth and assume, hey, it was perfectly, naturally designed to be exactly this size. But actually, we owe our lives to a monumental 1 in a million disaster 4.5 billion years ago involving a rogue planet named Theia. Talk about the ultimate cosmic butterfly effect. This infant planet, Theia, slammed directly into the young Earth. We're talking about an apocalyptic event that completely melted both worlds, but the magic is really in the aftermath. Theia's massive iron core sank and merged directly with ours, and that extra iron is exactly what keeps our core actively churning today, powering up that magnetic shield and saving us from becoming a dead world like Mars. Plus, the massive ring of debris from this impact clumped together to form our moon, which acts as a gravitational anchor, stopping the Earth from chaotically wobbling on its axis. If this exact sequence hadn't happened with just the right amount of force, Earth simply wouldn't be habitable today. No way. Act 3. The Galactic Dance. Okay, so even with our magnetic shield and our stabilizing moon firmly in place, our planet is still at the complete mercy of the gravitational bullies in our cosmic neighborhood. 405,000. That is the number of years in a massive climatic cycle our planet is subjected to. Every 405,000 years, Earth experiences this wild stretching of its orbit, triggering extreme seasonal shifts and dramatic deep climate changes. And who exactly is causing this? Well, the bullies on the playground, Jupiter with its massive gravity, and Venus, coming incredibly close to us, literally gang up on Earth. Their combined gravitational tug takes our normally circular orbit and stretches it into an extreme ellipse. When we get stretched closer to the sun, we get severe summers. When pulled further away, brutal winters. A 100,000-year variation of this very effect actually triggered deep ice ages. It locked so much water into glaciers, including a sheet of ice taller than a skyscraper sitting right over New York City, that global sea levels dropped. This created the land bridges that allowed early humans to migrate from Asia to America. Think about that for a second. Distant planets tugging on our orbit directly shaped human history.
And on top of all that, we aren't just moving around the sun. Our whole solar system is shooting through the Milky Way galaxy at over 500,000 miles an hour. Because the mass of the galaxy is unevenly distributed, Earth actually bobs up and down through the galactic plane like a horse on a cosmic carousel. This 60,000-year bobbing cycle physically drags our entire solar system through different, potentially dangerous galactic neighborhoods, exposing us to varying cosmic elements over millions of years.
Act 4. Weird life.
So, if the mechanics of the universe are this violently chaotic, how does that change our view on where life can actually exist? Let's travel way out to the rings of Saturn. About 4 billion years ago, a huge upheaval scattered asteroids all through the outer solar system. Saturn's gravity grabbed them, creating this deadly cosmic pinball game that smashed its early moons to absolute pieces. Out of this total carnage, one single survivor gorged on the debris, Titan. Titan swept up 96% of the orbiting mass around Saturn, growing so incredibly large that it developed its own thick, dense atmosphere.
When the Huygens probe finally pierced Titan's thick gloom, we found the only other place in the solar system with rain, rivers, and lakes. But there's a massive catch. The surface is 290 degrees below 0 Fahrenheit, so we really have to ask, could life as we know it even function in such unrelenting, brutal cold?
What is completely mind-blowing here is the sheer toxicity of this environment to humans. Those rivers and lakes, yeah, they aren't water. It literally rains liquid methane. It's as if every single gas station on Earth leaked all at once, soaking the entire world in hydrocarbons. And high up in the atmosphere, sunlight is constantly breaking apart nitrogen and methane, reassembling them like tiny Lego blocks into completely new molecules, raining down up to 10 billion tons of a chemical called vinyl cyanide right into Titan's lakes.
This is where the science gets truly alien. On Earth, our water-based cells use fatty acids to build membranes, right? But those just freeze and die below -4 degrees Fahrenheit. But on Titan, that vinyl cyanide we just talked about can actually form long chains, creating resilient, alien cell membranes that thrive in extreme cold. If life exists in those liquid methane lakes, it wouldn't just be surviving the cold, it would be biologically built entirely out of the toxic chemistry born from Titan's violent history.
So as we wrap up this explainer, we realize that the universe doesn't work through peaceful, gentle evolution. Earth's habitability is absolutely not a given. We owe our very existence, our oceans, our protective magnetic shield, and even the climate that drove human migration to the absolute cosmic mayhem of the early universe.
It really leaves us with a staggering thought to take away. If our perfectly balanced, beautiful home was forged in the fires of planetary collisions and gravitational bullies, well, as we continue to search the dark for life beyond Earth, what other bizarre, beautiful cosmic accidents are just waiting to be discovered? Thanks so much for joining me on this explainer, and keep looking up.